Okay, hello everyone. My name is Zhiwei, and I'm from Huawei Technology. And I'm focused on safe data process for 5 years. Today, my topic is about best UADK acceleration practice on safe storage. And I will show you the power to save 50% of CPU usage. Okay. My talk consists of 5 parts. And in the beginning, let's overview data process structure and overhead in Ceph. And then our solution can offload overhead to hardware, and what is it, and what ability, and how to use it. And then our practice on safe data process offload, including security and compression. I will show you our realization and the result. By the way, I will introduce some other optimization about safe data process. And last is our plan or our next step work. Okay, first part, overview data process on Ceph. Look at that picture. This is the Ceph stack architecture overview. We have found that from client to Ceph backend overstore, there are many data process features, such as client-side encryption, S3 HTTPS, to the Ceph daemon, there are RW compression, also server-side encryption, and MD5 computation, and SafeX message version 2 secure mode computation, also transform compression. To come to OSD and Blue Store. Okay, we have Blue Store compression and fingerprint computation of deduplication. Okay, at present tense device layer, disk encryption is the last defense of data security. We can classify this to 2 types. One is for space saving, and the other is for data security. As you know, if we want to enable these features, we will consider what algorithms are used and how much overhead the system will face. Look at this from top, this picture. When Blue Store, the lab compression is enabled, the lab hotspot is over 70% of OSD daemon. The other one, this one, the other one is the perf top of RGW. When enabled server-side encryption, when client upload object to Ceph, hotspot have MD5, AES, and SHAR. Okay, the challenge is how can we offload our overhead and optimize it? Then, my solution, UADK, is coming. What is it? UADK is a user space acceleration development kit. It has many advantages. The first one, Unity, is one set of interface to support encryption and compression acceleration based on hardware. Also, efficiency, because UADK is based on IOMMU and shared virtual address technology. There's no need memory copy between CPU and ACC devices. Security, the IOMMU limits the access right and the security boundaries of device and process. So, shared virtual address had the advantages than other solutions. Compatibility. It means any other devices can join the open source project to benefit from the IOMMU and shared virtual address technology. Until now, UADK had many abilities, just like this, have ciphers, digest, and compression. Also, until now, UADK has supported many algorithms, including cipher, digest, and compression. At the same time, it supports sync and async request mode. So, we have done offload practice on Ceph. The first one is about data security. We have two options. The first one is UADK engine based on OpenCL EVP interface. After Ceph Pacific version, the PR OpenCL engine support for RTW is merged. And we no need to change any Ceph code. We only should configure the OpenCL engine options and preload our UADK engine. Also, the engine support just like AES, MD5, and SHAR function overload. Okay, this is our source code. Another one is we have added a UADK encryption plugin in Source Crypto. It has a better performance and better encryption. It means if our hardware acceleration has attached its bottleneck, it can fall back to CPU software process. Okay, this is our test result. The result is based on UADK engine. It means this option. And the test is on the ARM platform with Quantum building accelerator. From this, we have achieved 50% of CPU usage. And at the same time, we can offload MD5 and AES to our hardware. We got it lower CPU usage and better performance. The other practice is on data compression. We also have two options. The first one, we add a UADK compression accelerator, a class with UADK API in source compressor. It means there's a new procedure branch in the lab compressor. Also, it support HW compression, Bluestone compression, and network transform compression. At the same time, you should choose the right compressor the lab inside because it means different algorithm header, deflate, GLAB, or GZIP. Okay, this is our source code. Another one, we have also supplied a GLAB patch file about just 500 lines of code. We should recompile the lab source file to get the new version dynamic library. But there's no need any Ceph code modification. Also, it supports multiple Ceph versions with the lab supporting. And we plan to open source it. Okay, this is our test result based on UADK compression accelerator. We can get that. We also save about 50% CPU usage. If we offload MD5 and GLAB overhead at the same time, we also get about 68% CPU usage. Okay, we got lower CPU usage and better performance. Okay, there are some other optimization work on Ceph data process. The first one is about the lab IC optimizing on ARM platform. We have enabled on Ceph and the compression platform. And the compression performance speed up from 4 to 7 times, and the PR is merged now. These are result details. Also, another one. Now, RGW can support four object encryption stack on compression. Before that, we need to choose between them. But now, I'll give you. And last is our future work, the 3 The first one, if you want to enable S3 HTTPS or CephX message version 2 security mode, we'll find GCM will be the hotspot. I think we need to resolve this issue. Okay. We also want to open source our effort and do some UADK support in Ceph Master, such as UADK crypto plugin and UADK compression accelerator. Also, now I mentioned we don't need to do choice between encryption and compression. So I believe chain mode acceleration on hardware is available and with less memory access frequency. Okay, that's all. Thank you.